Okay, so now we're going to start topic 5 today. 5.1, nth roots. That should be roots. Radicals and rational exponents. So, what is the cube root of 125? So, that is the cube root. The cube root. So, we put a 3 out here, right? Of 125. So, I'm going to write this a little different. You know what the answer is. What is it? 5, because it's 5 times 5 times 5, right? But we've talked about what a square root is, like an exponent. So this is 125 to the power. There's a 1 on this 125, yes? Yes. Over the root, which is what? 3? So it'd be 125 to the 1/3 power. So 125 is 5 cubed to the 1/3 power. So I'm just writing it a different way, okay? So when I have a power to a power, my exponent rules are to multiply, correct? So what's a third of 3? 1. A third of 3 is 1. So your answer is what? 5. Did we already know that? Yes. But are there going to be harder ones that we may have to break it down like that? Yes. Okay. So what is the 4th root of 81?
It doesn't exist in my mind.
So we're going to write it as 81 to the 1/4.
You might be right.
Okay. Listen, because a 4th is 1/4, yes? So to the 4th root, does that make sense where I'm getting that? Mm-hmm. Okay, so I need to think about 81. I can break it down to 2s. No, I can't 2s. 3s, yes? Is 3 to the what? 4th?
Yeah. Dude, Alex, you were right.
So 3 to the 4th to the 1/4 is just what? 3 to the 1st. I know what she was saying when you said 1, right? You were meaning?
Yeah.
Okay. See how that kind of works? So try the 4th. Try the 4th root of 16 on your own.
Oh. Ew. You good over there? You okay?
I think about it is I am feeling better.
When was like sound worse when you start feeling better?
Not 100%, but better.
Alex, shut up.
Okay. Olive, the whole world doesn't need to know how you speak to.
Oh, yeah, you are recording right now.
Okay. So how am I going to write it? 16 to the what power?
4.
1/4.
Yeah.
And if you're saying 4th, you need to say the really good, right? So people don't, yeah, 4th. And it's easier just to say 16 to the 1/4. So what is 16? You can break it down to 2. So 2 to the 4th to the 1/4.
Equals 2.
2.
To the first.
Okay.
Which equals 2. Don't be the same. Get it.
So what if I had not the 4th root? Yeah, the 4th root of 32. So I have the 32 to the 1/4.
4.
Yeah. Wait, what did you just ask?
32 to the 1/4.
Isn't that 4?
4.
2.
Mm-mm. 4 doesn't. 4 goes into 32, but it's 4 times. We need to break it down. So 2 is the smallest thing I can get it in, right?
Mm-hmm.
Okay. Well, 16 to the 4th. 2 to the 4th is 16, yes? And 16 times what gives you 32? 2. So it's 2 to the 5th to the 1/4.
Oh, that's great.
Okay. So 4 doesn't go into 5 evenly, does it?
No.
No. It goes in there one time And then how much do you have left over? Don't you have 1/4 left? Because when I multiply exponents, I add them, correct?
Yes.
So 1 plus 1/4, is that 5/4?
Yes.
Because this would be 2 to the 5/4. Yes?
Yes.
Okay, so 4 goes into 5 one time, so I get a 1. And how many were left over? 1. So if I were to write this back out, I would simplify it, of 2 times the 4th root of 2. See how that works?
Yes.
So what if I had 2 to the 6th to the 1/3?
Something.
Well, 1/3 of 6 is what?
6.
2. So it'd be 2 squared, which would be what?
4.
4. Okay, so what if I had 2 to the 6th to the 1/4? So that'd be 2 to the 6/4, yes? Which would be 2 to the what?
3 halves.
3/2. So 2 goes into 3 one time, doesn't it?
Yeah.
So it'd be 2 to the 1st times 2 to the, how many's left over?
2 and a half. 2 a half.
A half. So half means square root, doesn't it?
Yeah.
So 2 square root of 2. So you see how I can use those exponent rules to manipulate it and make it easier on myself?
Yes.
Okay, so we got one more. Okay, do that one. So if you know your squares and cubes, does it make this process really easy?
Yes.
Okay, if not, you're breaking this down. Because I know some of you in here went 2 times 32. And then 2 times 16. Or probably 4 and 8, right? And then 2 and 2 and 2 and 2 and 2. How many 2s do I have? 1, 2, 3, 4, 5, 6. I made a factor tree. I broke down 64. If I didn't know 64 was 4 cubed, is this what I'd have to do?
But you should know what it is.
You should, but I'm saying if I don't, is this a way to do it?
Yes.
So I'd have 2 to the what? How many 2s do I got? 6? To the 1/3. A third of 6 is,
2.
so 2 squared is,
4.
knowing my squares and cubes, will that make my life easier?
Yes. Yes.
If I don't know it, do I have to just keep breaking it down?
Yes.
Okay, real quick, I didn't review, and I should have. Okay, so when I had this, okay, this is a radical sign. It is not a square root because we already know that it could be a cube root, a 4th root, an 8th root, a 29th root, right? Mm-hmm. So it's a radical sign. This is an index. It's the root, okay? The root.
Root.
Okay, and this is the radicand. And I always say I don't put enough emphasis on the D so people hear it, radicand. Okay, so the number under the radical is the radicand. The index or the root is out here. And remember, it's fractional. So when you put it into a you put the radicand. And what's the exponent right here if there's nothing there?
1.
1. So power goes on top and root goes on bottom. So power, root.
What's the thing? What was the thing in the corner above the radical?
Power.
Power.
Wait. This right here?
Yeah.
The radical. It's just a radical sign.
Okay.
And I can't get root because it's too close to my end. But the bottom is the root. Okay, so what's that mean? Is all of these were nice and even, yes?
Mm-hmm.
Yeah? But what if I have, like, the 5th root of 17 to the 4th? So let's write it as an exponent. Let's write it like this. Okay, so what's my base? My base is my radicand, right? So 17. On top goes the power. That's the power of 17. 4. And what's the root? 5. So 17 is a prime number, yes?
Mm-hmm.
So can that reduce? No, because 5 doesn't go into 4, does it? Okay, reducing radicals is amazingly easy this way if you can use fractional exponents. Okay, I just wanted to go through that with you. Okay, oh, and this did it again. At least it's typed this time, right? So we have the radical, n is the index, and x is the radicand. And then the rational exponent, we already went over. It's the power over the what? Power. Power over, well, yes, index or root. Because on the other page, I called the index also the root, right? Okay, so what is 16 to the 1/4? It means what root of 16? The 4th root. And that 4 needs to be in there of 16. Now, we could break that down, couldn't we?
Yeah.
Isn't that just 2 to the 4th to the 1/4? Which is 2. Knowing your powers is what makes this so quick for me. Should you know several powers of 2?
Mm-hmm.
Yes. Other ways people write them, because this, guys, is not correct. What is wrong with that? The 4 looks like 4 times it, doesn't it? It looks like the answer to this would be 4 times 4, which would be 16. Yeah, 16. Because what's the square root of 16? 4, so it'd be 4 times 4, which you would get 16, but that's not the answer, is it? No. So some people like to do theirs like this. And put a little 4 there. Now, can you tell that it's the root? Yes. Just like I like to close my radicals. Some people don't do that. I think it helps me not mess things up. Okay, so explain what each fractional rational exponent. Fractional means rational number, yes? Okay, so what that means is, what is the base or the radicand? Base and radicand are the same underneath the radical. What is the power? What is the root or the index? That's what it means. Okay? So, what root is this? What root of it is it? What's going to go inside there? 3. And then what? 27 to the second. Okay. Because, Gracie, this is what you just said to me. And I'm just picking on you because you just said it, okay? I'm not picking on you for any other reason. You said 27 to.
Oh, I was talking about, like...
Right. No, what I'm saying is I'm just trying to get you guys is we have to say the words, right? Because we're describing more specific things than we used to. So we have to use the words that mean that. And I think I've been kind of picking on you guys since geometry about that, haven't I?
Yes.
Yeah. So I'm going to keep doing it. Could I break that down? 27. Could I break that down?
Mm-hmm.
To what?
9 and 3.
9 and 3.
And then 3, 3, 3.
So it'd be 3 to the 3rd.
Mm-hmm.
to the 2/3. And again, power to a power, you multiply, right? So the 3's do what? Reduce. So you get 3 squared, which is 9. Isn't that much easier than squaring 27 and then taking the cube root of it? I would hope. Okay. I think the next two you could do yourself. You think so?
Yeah.
Let's try it. So 27 to the 1/2. Hate that that's not better. 27. How about 25? And then 32 to the 2/5. So write them in radical form and then actually simplify it. And the whole reason to write them in the radical form is so your brain just starts doing it without doing it. Does that make sense what I'm saying?
Mm-hmm.
Like either way your brain sees it, they think the same. I'm tired of hearing me cough yet.
Yes, please stop.
I'm trying.
At least you're on top.
I'm trying.
Better not happen again.
Because at a point I can do it.
Mm-hmm.
Gracie, you're spacing. You have them done already? Cooper, how'd they go?
Good.
Did you do them? Then they didn't go good. Ask questions. What don't you understand? Gracie, what got you?
I don't know how to do this.
Okay, can you go from here to here?
Yeah.
Okay, can you go from here to here?
Well, I mean, I actually know how to do it.
Oh, I thought you said I don't know how to do it. I'm
I
sorry.
learned it in Mississippi before we left.
Okay, good. So, Cooper, what's getting you? Can you do from here to here?
I don't know.
Can you try next time so I can help you if you can't? Austin, how'd it go for you?
Pretty good.
Very good. Cole?
It's easy.
It's easy. Okay. Brandon?
It's easy.
Okay. So, does it come down to knowing your powers?
Yes.
Yes. If I didn't know 32, I'd have to sit there and break it down further and further. You already told me it went fine, Alex.
Which I did break it down further because I.
Yeah, because did you do 4 and 8?
Yeah, I did 4 and then I was like, okay, so 2 to the bit.
Yeah.
So,
So once, and if, as long as I'm seeing improvement, if you don't have to write 2, 2, 2, 2, if you can write 4 and 8 and say 2 and 3, that's 5, it's improvement, right? I know it's the 5th because I've done it forever. I know 64 is 2 to the 6th. Okay? So, powers of 2, I typically get you about 8 or 9. I expect you to know them. Okay?
is this all we're doing?
Yeah. Now, a lot of these we've done already. Like 32 to the 3/5 we've done, yes?
We should do the bottom 2.
Okay, that's what I'm getting at. So let's do these really quick. We'll just set them up. Okay, so 32. What is it? 2 to the what? 5th. So 2 to the 5th to the 3/5. So it's 2 to the
8, 2.
3rd, which is 8. You were right with 8. I was just trying to step through this. Okay? Okay, 50.
Something.
Well, 25, yes? And 2?
Yeah.
So it's 2. Ooh, this one is interesting. So 5 squared and 2 to the first to the 3/4. Yeah? And then my exponent rules say I have to what? Distribute, doesn't it?
Yeah.
Okay. Well, this might be interesting. So this is going to be 5 squared to the 3/4, and then 2 to the 3/4. Well, 2 and 4 reduce, yes?
Yeah.
Okay. Well, 2 goes into 3 how many times? 1 with one left over. So 5 to the first, 5 to the 1/2. And is this going to reduce at all? 3/4? No? Okay. So that doesn't reduce at all. So we're kind of in this like quagmire because I can bring out this 5, correct?
Yeah.
Okay. But I have 2 different roots here, don't I?
Yeah.
I have an index of 2 and an index of what?
5.
No.
But can't
2 and 4.
4.
Yes? And when I multiply exponents, I'm supposed to add them, aren't I? But I'm adding fractions. So I have to have what? Common denominators. So 1/2, isn't that going to be 2 over 4?
Yeah.
So I have 5, the 4th root of 5 to the well, we're just going to, because we put it in the 4th root, so 5 squared, and then 2 to the what? 3rd. Now we probably need to figure that out because we're simplifying. Well, 5 is easy. Whew, that was good. Okay. Well, 5 squared is 25.
5.
And 2 cubed is 8. So 8/4 is how much money?
$2.
So 200.
Yeah.
So I had to break it down to make it easier to do, but then I had to build it back up, didn't I?
No.
Now, a lot of times when I do something like this, I showed you because that's probably what you would have done. But personally, I would have said 5 squared to the 3/4. So I would have said 5 to the 6/4. If I would have just left it 6/4, would I had to get common denominators?
No.
No, because 4 goes into 6 one time with 2 left over, and you would have had the common denominators.
5 squares. But
5 squared is 25.
but it's not 50.
No, it's 25 times 2 is 50.
Yeah, I know.
So we have 25 and 2.
Oh, okay. That makes sense.
Okay, so what's a negative exponent do? Guys, remember?
You have to get an I, don't you?
Mm.
No.
That's a negative radical, but this is negative exponent. Okay, x to the negative 1 is 1 over x. 1 over x to the negative 1 is x. What happened to those two things? They're your favorite word to shout out when you don't know anything else.
Reduce.
Cancel them out.
No.
0 them.
Reduced was good. Cancelled is
0.
reciprocal. Aren't they reciprocals?
Cold. Yeah.
Aren't those reciprocals? So negative exponents reciprocate it. That's all that it does. So the answer instead of 8 would be what? 1/8. That's it.
So it's 3 halves.
So it's 1 over, because of the negative exponent, now it's gone.
Yeah.
Okay? 27. What's that?
9 times 3.
So keep 3 what?
3 to the 3rd.
3 to the 3rd. 2 to the 2/3. So 2/3 and 3. 3's reduce. And I get 3 what? Squared? Which is?
9.
So So it's 1/9. So negative exponents do not make things negative. They do what? Reciprocate. So in the numerator goes to denominator, and denominator goes to numerator. Okay, but this one, the negative is different. What's different about it?
There's a negative on the whole thing.
There's a negative on the whole thing. So I'm just going to do the problem and throw what on that? A negative. So 16, what can I break it down to?
4 squared.
Okay. Further.
2 to the third.
2 yeah.
Fourth.
2 to the 4th. 2 to the 3/4. And throw the negative on the end, yes?
Yeah.
So 4 times 3/4 give me just
2 to the
3.
third.
2 to the 3rd. So negative
8.
2 to the 3rd. So it's negative.
1/8.
Nope. It's not on the exponent.
Oh.
Negative on the exponent reciprocates it. Now I have a question for you.
Yes.
Negative 2 to the 3rd is negative 8. What is negative 2 to the 3rd?
8. Negative 8.
Negative 8. Okay? Doesn't make a difference, does it?
No.
So what is negative 2 to the 4th equal?
Negative 16.
Negative 16.
And then
And what is negative 2 to the 4th?
negative 16.
Positive 16. Okay.
Oh, yeah, yeah.
So this negative is thrown out after you do the exponent, yes? This negative is done first. So it'd be negative 2 times negative 2 times negative 2 times negative 2, which is a positive. This is something they love to put on your standardized tests. Love to do it. Because is it easy mix-up to do?
Yep.
Yep. Does it matter on odd exponents? No, because odd exponents is going to be a negative regardless. So you don't need to have to know the rule, but do you have to know the rule here? Yes. Okay, simplify each of the expressions. So now we're going to go from a radical and we're going to go into exponential to make it easier for us. Okay, so I have the 5th root of 32 m to the 15th. So 32. What are you going to break it down to? 8 and 4?
1/4 of the third. Right?
No, 4 and 8 is fine. So it's 2 to the what?
Third.
There's 3 here and 2 here. So it's
Whoa, how is that 3 and 8?
2 times 2 times 2 is 3 2s.
Oh, I thought we were going by 4s.
No, we want to break it down as much as we can. So this is 2 cubed and this is 2 squared. Yes?
So 2 to the 5th.
So 2 to the 5th, m to the 15th, all to what power? 1/5.
Yeah.
So I have to do what with that 1/5?
Distribute.
I have to distribute. And it's because it's multiplication in there, right? If it was addition, can I distribute?
No.
No. So Brandon, what do I get when I distribute? 2 to the what? Well, I have 2 to the 5th times 1/5, so I get 2 to the what?
1.
Well, what's 5 divided by 5?
Divided by
Mm-hmm.
1.
Because it'd be 5 times 1/5. Isn't that just 5 divided by 5?
Oh, yeah.
So it's 1. M to the what? Shh, Brandon.
So 15.
So I have 15 times 1/5. Don't listen to him, he's wrong.
I am.
What's 15 divided by 5?
15. This is what I use calculator.
15 divided by 5. You should know this one. What times 5 is 15?
Huh?
What times 5 is 15?
3?
Yes.
Good job, Brandon.
No,
It really looked like you had 4 fingers up.
How's that look like 4?
Because this, you, floor, sit. You, floor, sit.
See, like, how's that 4?
Okay. Alex, sit on the floor.
Who said sitting on the chair. not the
No,
floor.
you're tipping your chair, so now you get to sit on the floor.
Oh,
Okay, so, no, I'm serious, like, in the middle. Let's go.
okay.
No. Done it in every other class. Let's go. You're wasting our time. Okay, so let's go. Next one. The cube root. Sit in the aisle so you can see. The cube root of -8, a to the third, b to the ninth. So I'm going to help you guys out a little bit. This is kind of a trick that I got when I was messing it up a lot because I didn't want to remember which rule was for what. Could I just put -1 times 8? So 8 would be 2 to the third times a to the third times b to the ninth, all to the 1/3. So now what do I do with this 1/3? Distribute it to everything. Well, what is the cube root of -1? Think hard, guys. Really hard. -1.
-1.
Yes?
Yep.
Okay. So 2 to the third to the 1/3 is what?
2.
Hmm?
It's just 2 to the first, so it's just 2.
Oh, okay. I thought you were saying 2 to the second.
Oh, no.
Okay, so I just get 2. A to the third to the 1/3 is what?
Just A.
Just A. It's A to the first, if you need to write a first there. B to the ninth to the 1/3 is B to the third. So my answer is -2AB cubed.
Oh, yeah.
Not that bad. Now, can I answer it all at one time?
No.
No, you have to break it down. And can you break it down in your head as you get there? You will, eventually. But right now, you need to do some work at it, right? Okay, so this one should be pretty easy because I don't have any numbers involved, like coefficients, right? So x to the 20th, y to the 8th, all to what power?
4.
1/4. So finish off your answer. Cooper, x to the what?
5th,
Mm-hmm. Y to the?
2nd,
Good job. That was pretty easy with no numbers, right?
Yeah.
What's wrong?
so all you do
I'll
is
tell you
change
what's wrong with me.
Like, you're sitting on the
4 to
floor.
1/4, put that to you.
You're just multiplying this in. So 1/4 of 20. So 20 divided by 4. 8 divided by 4.
So do I, like on the next one, do I take it into 256?
Yeah. So we need to break down 256. Am I interrupting?
No.
Okay, so 256, what should we know? 256, that's a number we should know.
12 and 12, right?
2
no.
probably goes in
No, that's not 12 and 12. What was the other one?
the,
13.
7.
15 has to end in a 5.
13,
64.
I said.
16 squared. 16 squared is 256.
I was close.
Okay? What do we know 16 breaks down to?
4 and 4.
More. 2 to the what?
Oh my
6.
God. 4.
So I get 2
You're smart.
to the 4.
You're sitting on the floor.
Okay, guys, come on. 2 to the 4th to the 6th is 2 to the what? 2 to the 4th to the 2nd is 2 to the what?
What?
Throwing too many numbers at me.
Right here. 2 to the 4th to the 2nd is 2 to the what? 8. Okay, x to the 12th, y to the 24th. So Cooper, yeah. All to what power?
4.
1/4. Okay. So 2 to the what?
Second.
Second. How'd you get second?
Just distributed to 1/4.
Mm-hmm. X to the what?
Third.
Y to the? Last step. Can't leave it like this. 2 squared is what, guys?
4.
So 4x cubed y to the 6th.
We're so smart. Okay.
So we break it down and then distribute those exponents. That's what you're going to be working on today. Might go to switch. I think that's all. Oh, okay. This is easy. Okay, so 2x to the 5th. 2x to the 5th equals 64. So what do I have to do first?
0. You have to get the 0 and do you.
Any algebra equation, guys. 2 to the x equals 64. What do you do?
Oh,
You get
divide.
Divide by 2. Yes? X to the 5th equals 32.
Is that it?
No. Okay, so we got to take the 5th root, right? To get rid of the 5th. So 32, break it down. 32 is what?
2 to the 5th.
2 to the 5th. So x to the 5th equals 2 to the 5th. Well, guess what? If these exponents equal, the answer is what?
2.
2.
Oh, and goodness.
Oh my goodness.
Okay, 2p to the 4th equals 162.
Divide by 2.
Divide by 2. So p to the 4th equals 81.
Yeah.
So p to the 4th equals,
2 to the 4th.
no,
3 to the 4th.
3 to the 4th. 2 to any power is even, Emma. So p equals,
3.
Oh, yeah. What?
Uh-huh.
It's high.
oh, never mind. Yes, you're right.
Say, you're like,
Okay, do the next one.
Grace, I didn't do 6.
Can I start?
Yeah.
Did you say no?
No.
Did you say no?
You definitely did.
Okay, I did.
Okay, so I'm waiting.
No, I was joking.
Oh,
Please start.
okay, problems that looked impossible when we started today, are they very hard?
Yes. Very difficult to say.
Now, technically, I think if you looked at these in the book, they would say this. We should do them like this. And I don't know why you should do them like this. Okay, so you would have to take 1/5 here. And if you did it here, you'd have to take it where?
No side.
There. So you'd have, no. So you'd have x equals 2 to the 5th to the 1/5. So the answer is what? 2. Do you see how this is much easier?
Yes.
Yeah. Done.
What's our assignment?
Oh, your assignment is,
Read it to us.
yes, I'm going to write it right here. So it's 5-1, page 244, 7 through 16. Now, they're the short assignment, so I expect you to do it. So tomorrow we can go over questions so you can have your long assignment. Got it?
So if we don't do it,
I'm saying.
So don't do it so you don't know if you know how to do it? That doesn't make sense.
no. So
I'm just going to start making assignments one day then. That's what you guys are going to do.
Alex is just really